everybody, welcome to my channel Advanced City Learning Videos. Okay, so today's class will be a continuation of previous classes. That was last week's class on differentiation. Alright, so today we are just going to solve questions which require differentiation but then using a different method altogether. And this method is the first principles, so stay tuned. But then before that, I would like to thank all of you for massive subscriptions so far. I'm grateful. I'm really grateful. We are almost hitting 400. Yippee! Oh yeah, thank you so much. Okay, so stay tuned for the upcoming class. Okay, so from normal differentiation, anytime you find something like this, what we're going to do is from indices first of all. From indices, this is the same as s to the power negative 1. So this requires the power rule. So from the power rule, we've already talked about it. So what we do is we multiply the negative 1 by the whole thing. Then we subtract 1 from the exponent again. So we subtract 1 from the exponent. We are going to get negative x to the power negative 2, which is the same as negative 1 over x squared. So this is what we would have solved, or this is how we would have solved it. But then this is a case whereby we are using a different method altogether. We have to use this method to arrive at this answer. So stay tuned, just get the way I solve it and it will help you solve a lot more. So first of all, I would like to give the formula for solving questions using the first principle method. Alright. So you have your f of x. So this is the function that you are going to differentiate using the first principle. So what are we supposed to find? We are supposed to find the differentiated one. So f prime of x. Yeah. And this is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the formula we are going to use. The formula is actually easy to, it's quite easy to memorize, but then how to go about it is quite difficult. It needs a lot of basic mathematics. Sure. So stay tuned as I proceed. Alright, so from here, for the question given was 1 over x. So 1 over x, that means wherever you see this, you're going to put 1 over x. So f of x is given as what? 1 over x. Then what will be f of x plus h? It will be 1 over x plus h. So this is what we are going to get. I know you're a little confused, but then let me give another example, then we'll see how we go about it. So imagining f of x is equal to s squared. What will be s plus a? So imagining f of x, so another example. Imagine f of x is the same as s squared, then what will be f of x plus h? That means wherever you see the x, you put x plus h. Can you see that? Sure. So we are going to get x plus h squared. Can you see that? Good. So let me give last one. F of x is equal to s3, so s to the power 3. What are we going to get for x plus h? We are going to get s plus h exponent 3. Alright, so with that said, we are going to go straight to the formula. So let's solve them. So that means our f of s plus h is going to be 1 over s plus h minus our f of s is what? 1 over x was given in the question. So when we get here, what do you do? First of all, you set. So when you get here, what do? you first of all solve for the 1 at the numerator. So the numerator, which is 1 over x plus h minus 1 over x. So you manipulate and you simplify that part before you could divide by the h. So from here, you can do it somewhere, or you can still put it in your work as evidence. So we are going to find the LCM. So the LCM is going to be s plus h, then x. So when s plus h goes into s plus h times x, what are you going to get? We're going to get x. It looks too clumsy. Sorry. So, as I said, you're going to get x minus s goes into s plus h times x is what? S plus h. Can you see that? Yeah. So from here, you just simplify. So you simplify this part. We are going to get negative h over s plus h s. But mind you, everything is divided by h. So now for the numerator, that's the first part, we're going to get negative h over s plus h times x. Let me bring my limb. Okay, so with this is divided by h. Divided by h. So what do we do? What can we do here? So when you simplify, you're going to get lim as h approaches 0, negative h over s squared. I'm multiplying through, so plus hx times h. So that's what we're going to get. Can you see that the h's can cancel out? Yeah. So we're going to get lim of h, which is approaching 0, negative 1 over s squared plus hx. Anytime you get to this part, the only thing you can do is wherever you see h, you put in 0, because it said h approaches 0. So wherever you see h, you put in 0. So from here, you're going to get limit as h approaches 0. Sorry. Negative 1 over s squared plus 0, because 0 times any number is still 0. Can you see that? So we are done with that part. That means we're going to get negative 1 over s squared, which is the same as negative x to the power negative 2. Yep, we've come back to the main thing that we solved using the normal differentiation. Yes. So first point is supposed to help in solving questions which need differentiation. Alright. I will solve last one. Then we close for the class. So for another question, f of x is a squared. Mind you, f of x is not always f of x. It can be g of y, anything. So I like using f of x. So it doesn't really mean you're going to use f of x throughout. So with this, what are we going to do? I'm going to do it very fast because now we understand. All right. So from here, we are going to divide through by h. So we can simplify this again to get can you see that? Sure. So after doing everything, we are going to get limit of h approaching 0 to x plus h. Then whenever you see h, you put 0. So you know we are going to get f of x to be 2x plus h, which is 0, 2x. Now let's use the other normal differentiation. Our f of x is equal to s squared. From the power rule, what are we going to get? It said the exponent is coming down to multiply the whole thing, then you subtract 1 from the exponent. Come back to the same thing. Alright, so this will be the end of our class.